In this study, we examined whether recruitment of the right posterior temporal cortex is necessary for talker-specific phonetic processing. The acoustic phonetic details of a speech sound may differ subtly from talker to talker. For instance, some talkers might produce sounds like k with a relatively short voice onset time, whereas other talkers might tend to produce those same sounds with a relatively long voice onset time. Previous work has shown that listeners can quickly learn what variation is typical of a talker, and Bayesian accounts of speech perception suggest that in order to determine the phonetic identity of a speech sound, listeners incorporate their implicit beliefs of how different talkers talk. The current work was motivated largely by a previous study from Myers and Theodore, who exposed listeners to two talkers, one who produced the sound k with a relatively short voice onset time, and one who produced it with a relatively long VOT. After exposure, listeners were asked to indicate which of two variants, a short VOT or long VOT variant, was more typical of the talker, and they tended to select the variant that was more consistent with their training. Afterward, listeners completed an MRI session, during which they performed phonetic categorization, and critically they heard both short VOT and long VOT variants from each talker. Myers and Theodore found that the activity of the right middle temporal gyrus was sensitive to whether the phonetic variant was typical of the talker. They suggested that the right MTG might be recruited for processing talker-specific phonetic variation. Here, we asked whether the right MTG is necessary for doing so. So in the current study, listeners completed 3 experimental blocks. In one block, transcranial magnetic stimulation was applied to the right MTG, in one block to the left MTG, and in another block, TMS was applied to a control site scalp vertex. Each block consisted of a training phase and a test phase. During training, listeners heard a pair of talkers, one of whom produced a voiceless stop consonant with a short VOT, and one who produced the same consonant with a long VOT. Listeners completed a 4 alternative forced choice task indicating both who was talking and what they said via button box. TMS was applied prior to each trial, and participants received feedback on their responses. During test, listeners heard both a long VOT variant and a short VOT variant from one of the talkers, and they had to indicate which was consistent with their training. No TMS was applied at test, and no feedback was given. Listeners performed the training task with near-ceiling accuracy. We found that some listeners were worse at the phonetic decision component following right MTG stimulation, but this difference was not statistically significant. So this tells us that right MTG stimulation didn't strongly influence a listener's immediate ability to process talker or classify phonemes. We were particularly interested in whether right MTG stimulation might influence a listener's ability to learn what phonetic variation was typical of a talker, and for that, we can turn to the test data. Numerically, the learning effect was largest following right MTG stimulation, intermediate following vertex stimulation, and smallest following left MTG stimulation, but the interaction was not statistically significant. Overall, our results suggest that recruitment of the right posterior temporal cortex might not be necessary for determining what phonetic variation is typical of a talker, but there are a few important points to consider. It's worth noting that Myers and Theodore observed differential activation of the right MTG during a phonetic categorization task, and here we tested for effects of TMS on a talker typicality judgment. It would therefore be informative to test whether TMS yields similarly modest effects across different paradigms. It's also worth noting that the current task was relatively easy, and it might be informative to test for effects of TMS in a slightly more challenging task, perhaps one in which listeners hear ambiguous stimuli or have to contend with some degree of background noise. Finally, it's worth noting that we applied TMS prior to each training trial. In future work, it might be informative to apply TMS prior to each test trial. Overall, the fact that we observed relatively modest effects of TMS in the current study is consistent with the view that talker-specific phonetic processing is achieved through bilateral recruitment of the posterior temporal lobes. So that is, even though phonetic processing tends to be left lateralized and talker processing tends to be right lateralized, both processes entail bilateral recruitment. Interfering with the function of one hemisphere may have minimal behavioral consequences for integrating phonetic detail and talker information.